everybody, and welcome to this Mathigon webinar on exploring data science tools on Polypad. I am super excited you are here tonight to learn about how to use some of the tools on Polypad to dive into some data science explorations. My name is David Poras. I am the head of content at Mathigon. I am a middle school math teacher in Massachusetts in the United States, just outside of Boston. Thank you for coming out tonight. If you want to drop in the chat where you are in the world and maybe your role in education, it's always wonderful to see who's joining these webinars. I'll get started a minute or two past the hour as we're waiting for people to come on into the webinar. But again, welcome. I'm really excited that you're here to explore data science on Polypad. We have a lot of really exciting tools to use on Polypad to help students explore ideas about data science. If you are live watching this webinar, again, if you want to introduce yourself in the chat, it's always great to hear who we have with us. Hi, Amina. Welcome. Glad you're here. And I will get started in a minute or so. If you are watching this webinar after the fact in a recording, welcome as well. Thanks for checking it out. I'm really excited you're checking out this video to learn about how to use data science tools on Polypad. So let me jump in here. Here I am at Mathigon.org. Mathigon.org is a mathematical playground that has free manipulatives on Polypad. That's where we'll be spending time this evening. Courses, manipulatives to make online learning more interactive and engaging than ever before. And I'm excited to share some of those ideas with you tonight. Everything I'm going to do on Polypad, in fact, everything on Mathigon is free for teachers and students around the world. It is free to make an account. You don't need an account to go explore on Polypad. If you want to try to follow along with me as I'm doing it, you can. But it's certainly helpful to make an account so you can save your work. You can create tasks for students and do all sorts of things in your Mathigon account. So I'm going to go to Polypad. I can click this blue button here to launch Polypad. I could also go to Polypad on the top of the canvas. So I will go to Launch Polypad, and this is our open canvas for exploring mathematics. We have a number of categories of the virtual manipulatives on the side. There's a geometry section, numbers. In each category, you expand the category to see the tiles that you can put onto this white canvas. There's a fraction section, algebra, and we're going to be spending most of our time in probability and data. Hello, Carol. Welcome from Pennsylvania. Great to have you here. As people are coming in, if you want to introduce yourself in the chat, that's great. I'm going to share with you a number of lessons and activities, and all of these can be found on our lesson plan page. So you can see at the top of my canvas, it says lessons. If you have a student account, this does not appear. Or if you are at Mathigon.org and you click on Polypad and you don't have an account, that may not appear as well. So you can make a teacher account, or you can get there by going to Mathigon.org/tasks. I'll put this in the chat in case you are following along and don't have an account yet. So I'm going to go here. I actually have it open in a new tab, Mathigon.org/tasks. You can see it up at the top. And the first lesson plan that I want to share with you is called What Chart is Best? So you can see there's a growing library of lessons, puzzles, games, and so on. I know that the one I want to find to share with you is called What Chart is Best? So I'm just going to type here in the search menu, what chart? And there it is, what type of chart is best? I'm going to open it up in a new tab so I can come back to this task page as needed. And this is a full lesson plan. You can come back and read it as you like. It's got overviews, objectives, warm-ups, activities, and so on. I am using this to get a link to a Polypad. Hello, Brenda from Chicago. Welcome. And so the Polypad that I'm going to use is just all the way down here at the bottom. Again, I'm just showing you how to find this. So if you want to come back to this task, you can as well. So I'm going to click on this, and you can see it's a pre-made canvas with a couple of tables. I'm going to zoom in a little bit just to this first table. These are from this is some data from the Tokyo 2020 2021 Summer Olympics that took place this past summer. I put this data in a table under the probability and data section under charts and statistics. There's just a blank table. So you can see here, I can click on the table and it puts a table on the screen. Let me delete that. I can click and drag and put it on the screen. I can change this. I call this country, and then I just entered in the data. And there are these black tabs that you can click and drag to change the size of the table. As you notice this, every tile on Polypad, when you click on the tile, an action bar appears, and the actions are different based on the tile that you have clicked. So this was just my example. I don't need this tile. I'm going to delete it, and you can see one of the tools is delete. So I'm gonna delete that. In this lesson plan, the task for students is to decide what chart would best show the data that I have in the table here. So I'm going to start with a column chart. I'm going to click and drag and put that chart on the canvas. So there's my column chart. Now you can see that the data isn't graphed yet on the chart. What I need to do is attach this table to the chart. And you notice that when I click on the table, there's a blue triangle that appears. If I click and drag on the blue triangle, it makes a little bit of a wire. And if I attach that wire to the table and let go, watch what happens. There is the chart graphed. I'm going to make it a little bit bigger just for our purposes there. So there's a bar chart. It has the number of golds, silvers, and bronze for each of the countries. So really easy to make charts that are connected to data that you have in the table. If I unconnect it and then connect it again, it makes the graph. I can change the colors of these. I'm not going to go through and change them all, but I will double click on the red bar and you can see all the red bars are chosen. And I can go down here to the color wheel. That kind of looks gold. I'll click on that. There we go. That's gold. I can click on the blue one. What's that? Silver. Maybe I'll do this one. And I'll leave the green one for now. But you can change the colors of those. What's really nice, though, as you may notice, when I click on the bar chart, a number of options appear at the bottom. So right now I'm in just a bar chart. When I go to stacked, watch what happens. They're stacked. So it put all the bars on top of each other. Or percentage, right? And what I really like about this data is the story that's told kind of changes based on the chart that I have. So I could go to grouped. I might say here, it looks like the United States won because they seem to have the largest total number of medals, right? But maybe it's China. Oh, they have, they have the number of gold is one less. If I go to stacked, again, that's an easier visual representation of the total. But I really like the percentage one because now I can see from that chart that Japan had the highest percentage of their medals were gold. So maybe an argument could be made that Japan should be the country that's determined the winner of the Olympics. I wouldn't say all that with kids. I would just say, go make a chart and talk about what you notice and wonder about the chart, right? I'm just talking through what observations that my students could make about this chart. The other thing that is really nice, I'm just going to get that text box out of the way. A table can be linked to multiple charts. So if I want students to see all the charts at once, I'm back to the red and blue, but I could put all three charts on the canvas, and maybe I'll attach this one over here and do another arrow all the way around, and there we go. And I could do, that's the stacked one, that's the grouped, and there's the percentage. I could change the colors and have all three of them on the canvas and have a conversation about which one of those charts they think is best. And then which one's the worst, right? Like that's often a fun activity for students to talk about which chart is the worst one, to associate with this data. So I'll grab this one and put it on a line chart, and a line chart here like really makes no sense, right? So I can also change the chart type at the bottom, right? I didn't mean to click there, but that was a good thing to notice. I can click on column chart or a row chart, which is like the column chart going horizontally, line chart, and then an area chart. And those aren't great ways to tell the story of the number of medals that have been won by each country. I think this is really powerful to quickly have that conversation about what the chart tells us about the data. It's easy to create. It's easy to switch back and forth between the chart type and can generate some really good conversation with students. I'm going to skip the times and the world records. That's a good one to do in a line chart, but I just want to show you are pie charts as well. So here is data of the continent of the games from 1972 through 2002. Same thing, I can drag this and attach it to the chart. I can make this bigger, smaller. I could change the colors of this one. Maybe I want this one to be green and this one to be blue for whatever reason. That's not good, having two blues. Let me change that back to red. There we go. And you can change that to a donut chart if you like. If you like having that circle in the middle, I'll go back to a pie chart. And just to share that these tools that I'm showing you work with all of the other tools and tile types on Polypad as well. So I can go to the geometry section and under utensils, find the protractor, and it snaps right to the center of that pie chart. So if I want students to do an accurate calculation of the angle measure of each of those regions, I can put the protractor on and I can spin it, make it bigger and smaller, and measure the size of the angle with the protractor. So that's a quick overview of how the charts work. At any point in the webinar, if you have any questions about what's happening, about Polypad, feel free to drop those in the chat. I'll be paying attention to the chat as we go on. I'll show you in a few minutes some places to get additional information here, but I just want to invite people, as you have questions or comments, feel free to drop them in the chat. All right, but let's keep going here. I have so many more things that I want to share with you. Those are the charts. You may be familiar with the idea of a slow reveal graph. There's a great math teacher in Massachusetts named, her name's Jenna Labe, and she has a great account on Twitter that shows all sorts of slow reveal graphs where the story changes and you ask students to make predictions based on what they see in the chart. So I want to share an example of that with you, of one that I made on Polypad, and then I'll show you where you can find the information. I don't want to show it to you yet because I want to do the slow reveal. All right, so here in the top left, I'm in tiles. I'm logged into my account, and so I can go to File and see all my saved Polypads. I have a lot of saved Polypads. As I said at the beginning, I'm a full-time middle school math teacher in Massachusetts and also the head of content for Mathigon, and I really love talking and sharing about all the things that are available on Polypad. So let me open up a canvas for you that's called Slow Reveal. And so I'm going to turn that off. I collapsed the file menu, and here's a graph. And so the protocol in a slow reveal graph, you can Google slow reveal graph. It'll take you to a website that is made by Jenna with all sorts of awesome graphs that she has made. The protocol is you have a conversation with students about what they notice and wonder about the graph. But what I really like on Polypad is this is the table here. I've covered the data with a polygon so you can't see what the data is, but I've allowed myself to move this black tab. And as I change the size of the table, you can see the graph changing in real time. And I think it's really powerful as I've done this activity with students to talk about, you can see like an animated change happening in the graph. So what's happening as I change it? And that would be a great conversation with students to have. And then I might show the x-axis of the graph. So, this is just a polygon tile that I made and put on top of it. I'll hit delete, and we can see this is from 2010 to 2020. So that might give some more information to students about what are things that change from 2010 to 2020. Feel free to drop ideas in the chat if you want. And then I'm going to show the y. And again, you have the conversation with kids and have them make some predictions about what this graph is all about. I'm going to get rid of the y-axis now, or get rid of the polygon covering it. And we can now see that these numbers are going from 0 to 100. So now, again, you'd have the conversation. What do you think this graph is about? It's things that are changing from 2010 to 2020. It's on a scale of 1 to 100. Both charts are going all the way up to 100. And then after further conversation and predictions, I would delete the polygon on top of this one. There's a table of data. And before I show them what those letters stand for, they again have the conversation. What do you think those numbers are representing? And then I'll jump to the conclusion here. This is the percent of the population in the United States on the census that identified in those categories. So A is white alone, not Hispanic or Latino. B is black or African American alone, not Hispanic or Latino, and so on. And this data, comes directly from the website of the census. And so here, like we'd go back to the chart and say, what's happening to this place as we go from 2010 to 2020? Students might think this is the entire country, but the final piece of this is under this purple polygon, shows that this is the data for the state of Nevada. And so this whole story came together, for students, that there were, as you may know, significant shifts in the population in the state of Nevada from 2010 to 2020 that had an impact on the election in 2020. And so I think doing this in the protocol of a slow reveal engages students in that conversation about what's happening to the data. You can clearly see how that data is changing. If this activity is something that you might want to do with your students, I'm going to go back to our task page, just at mathigon.org/tasks. And this lesson plan, I'm trying to remember the name of this lesson plan, demographic. I will find the lesson plan. It is down here somewhere. If I search for data, there it is, the racial and ethnic diversity in the United States 2010 census and 2020. So you can click on that. Here's a whole lesson plan as well as a link to that Polypad that I just shared with you. So I think that's a nice use of the data tools as well. Awesome. Any questions, drop them in the chat. I'm going to keep going on here and shift from kind of data science graph tools that I showed you how to use a bunch of the graphing tools on Polypad here. This, again, probability and data was under charts and statistics. We looked at a column chart and a row chart and how you can cover parts of the chart to hide those from students. Let me show you the way that I used a polygon to cover parts of it. I went to polygons, put a rectangle on the canvas, changed the size of the rectangle, spun it in place as needed, and then I just put that on top of the graph. And when I was ready to not have it cover the graph anymore, I just hit delete and it went away. All right, I'm going to keep going, but let me show you where you can learn more about all of these other tools. If this is your first Mathigon webinar and your first time kind of experiencing Polypad, there are all sorts of places to learn more, not just about data and statistics. I'm going to click on the question mark on the toolbar over on the right. And the first option here is help and tutorials. And if I click on that, it brings me to mathigon.org/PD. I'm going to drop that in the chat as well. And again, if you are new to Polypad and you're here to learn about data science but want to explore other aspects of Polypad as well, here are some getting started pages based on the age that you teach. Here are some user guides for all of the tile types. Again, we're focusing tonight on probability and data. Here are the past webinars. You're here right now, Exploring Data Science. We did a webinar a couple weeks ago on puzzles, games, and art, logic and computing, algebra, and so on, geometry, numbers and fractions. And if you're a teacher and you want to learn about how to use this with students in terms of making classes, getting your students in the class, how to share Polypads with students, how to sync to Google Classroom, and so on, here are a number of tutorials to help you out as a teacher. All right. But let me move on to some of the other probability tools that I'm excited to share with you. Again, this is mathigon.org/PD. I want to go to our task page and show you where I can find this next activity. I'm going to search for class openers. And this task has a number of class openers. One that is called predict 50 roles. I'm going to open that, and here's how this task goes. It's got dice on the canvas that we haven't seen yet, a table, and a chart. And so the first thing, you just ask students to predict how many 1 through 6s are going to come up in 50 rolls of a dice. I'll be fairly boring in my prediction and go 8, 8, 8, 9, 9. And then I'm going to click and drag all of the dice and roll them. And I click roll, and I enter in the data that I got. Oh, first I want to attach the table to the chart. So I attach it. There's my prediction, 8, 8, 8, 8, 9, 9. And now students go through and they count the number of ones they got. What do I have? 2. Oh, and notice when I enter in the 2, the chart updates in real time. So as I put the data in, it's now updated in the chart. I got 4 2s, 2 3s, 1 4, no 5s, and a 6. Right? And depending on what you might want to do, you could have students update their predictions now. Oh, I didn't get any 5s. Maybe I'm going to make this 7. I went down 2, but I seem to get a lot of 2s, so maybe I'll make that 10, right? I'm updating my predictions as I go. You could have students update their predictions or not update their predictions depending on the goal of the activity. I didn't get any 1s. 4 plus 3 is 7. I'm glad I updated my 2s. That becomes a 5. Ooh, 4 of those now. Again, no 5s. That's wild. And 2 6s, right? So should I update my prediction some more? I'm going to keep it. I'd roll again. Let's just see if I get any 5s. Oh, there's my 5, right? But what's great about just this really simple kind of warm-up activity, maybe second, third, fourth grade, practicing their addition facts to all of these numbers that you predicted add up to 50. The chart is changing in real time so they can see the numbers that they're getting, how it's impacting against their predictions. Also, I think just when you roll the dice and you have students count the number of 2s, right? How are they seeing that that's 3? And then, I rolled that by double clicking on it and I got a 2. And then just updating the addition in the table is good practice for students. I'd have them do that, each student do it 50 times, and then have them talk to each other. What number came up a lot more than others? I was getting a lot of 2s, right? My 2 bar is probably going to be really high. Is that the same for the student next to me? Then what happens when we put all the data together, right? If there's 20 students or 30 students doing 50 rolls each, we've now generated 1,500 rolls of a dice. And we could graph that as a whole class, either on a Polypad individually, all together. And what you'd probably find is those spikes that individual students had wouldn't be there in the rolls of 1,500. And I think that's a really powerful activity for students to see that when you roll 50, you might get a few numbers coming up a lot more than others or not as much. But the more data you put together, the more the bars will come out to be about the same. So a really easy, simple activity that I think gets at a lot of the good data science questions you can have with students as young, probably as first, second grade, even up to middle school, just having that conversation about what happens the more data that you put together. Let me just show you some additional examples of data collection. I want to share our dice here. So I just showed you our dice that you can roll. There's coins to flip. You can flip the coins. We have spinners that you can change the number of regions of the spinner and then spin it, or a custom spinner where you can change the size of the region. So if I want the orange to come up a lot, I can click on the circle. See how as I move on the circle, let me zoom in a little bit onto this spinner, my cursor changes from the arrow to the plus sign. And when I click when it's a plus sign, I've added a region onto the spinner. And if I want to get rid of a region, I can click on the black circle and it goes away. So there is a custom spinner. And if I have a spinner and I don't want students to change the size of them under this gear, I can turn off show handles. And now it's a spinner that I can't make changes to by accident. And the final thing to share before I talk about the next activity is under polyhedral dice, we have 4-sided dice, 6-sided dice, 8-sided dice, 10, 12, and 20. And all of them can be rolled at the same time, which is really fun. All of these tools in probability can all happen on the canvas at the same time. And I'm going to show you a really nice example of that. I could do all of these at once and create all sorts of random data. Awesome. Let me just go pop in over the chat, make sure I'm not missing any questions that people may have. If you have any questions at all whatsoever, feel free to drop them in the chat. I hope these activities that I'm sharing are of interest and maybe some use for you in your classes. But at any point you have questions about what I'm doing, feel free to drop that in the chat. All right. What I love again, as I mentioned, I'm a middle school teacher, so I'm going to share some examples of what I've done in middle school. But it's really easy to take these examples and modify them both for younger students and older students. I love being able to generate large data sets with students in a way that for them is like fun and engaging. So the one example that I want to share is, let me just go to a new Polypad. I'm going to click on Polypad at the top. I want to put a number of sets of 3 coins on the canvas. And I just want to show you how easy this is to do. I'm just starting at a blank canvas. There are 3 coins. I'm going to click and drag. I could copy with this button. I can also copy just with the C button on my keyboard. So I just clicked the C button, and I'm making a bunch of copies of these. And within a matter of seconds, I have 5 sets of 3 coins. I'm going to copy this, and there's 10, and 15, and 20, and 25. And let me copy this whole thing. Oops, I missed. I'm going to give myself a little bit more room and copy this whole thing. And just in a matter of what seemed like 30 seconds, I made 50 sets of 3 coins on the canvas. Now, when I was doing this in class, I made this in advance. I saved it. I shared it with my students. The beautiful thing is I can flip all of these coins at once. Isn't that just fun to watch? It makes a nice kind of sound effect. Students enjoy that, right? I found that my students in middle school, they enjoy flipping 3 coins 50 times here. If I actually gave them 3 coins and said, flip it 50 times and keep track of the data, I lost them. They'd be flipping the coins. It'd be making noise. It'd be chaos. The focus would be on like maybe the fun for a few minutes of flipping coins, but not on the data. And so my question for them before I did it, I actually just started with some actual coins. I think I did this first with actual coins. There's a time and place for physical manipulatives in the class. There's lots of things that I do with probability with actual dice and actual cards. And then here are some benefits of the virtual. I took some coins and I flipped it and I wrote down what I got. Heads, tails, heads. And I did it again. And tails, tails, heads, right? And I did it a bunch of times. I kept track of those on the board. And I asked them, how many times do we think it's going to be tails, tails, tails? And this is before we had really done a deep dive into probability and making the trees and the list. Just what does your gut tell you about the probability of getting a tails, tails, tails? And I think what happened is what's happening here, where I didn't get it a lot, which I was kind of glad about. And so students thought it'd be really unlikely to get like tails, tails, tails. I got one there. That's exciting. And then I said, all right, let's go collect some data. And so I shared this Polypad with them. And I had each student do it, I don't know, maybe 10 times. And I had them write down how many times they got a tails, tails, tails. So there's 1, there's 2, there's 3, right? And then, so that was 50. Then they did it 100 times and collected the data and so on. And so let's say I had them do it 10 times. They got 500 trials of flipping 3 coins in a matter of minutes that they kind of enjoyed. And in fact, I think they believe the results because they saw it happening, right? Obviously, there are websites that you could go to. We could have students code it, flip 3 coins 1,000 times. How many of them are tails, tails, tails? That's a great activity to code. But I think sometimes students don't believe the results when they just see the number on the screen. Here, they're actually seeing what happened. And then we put all the data together. Each, I think I had them put their data together in groups, and then they share it out. And I put them in a Google Sheet. And so here's all the data from, that's a different one. Here's all the data from a couple of my classes. And you can see just all the way down is how many out of the 50 were tails, tails, tails. And that class flipped 3 coins 9,750 times, which is a huge amount of data, right? And the number of times that it was heads, 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 or tails, 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 which was stars, was 1,216 out of the 970, which comes out to 0.1247. And as you probably know, the theoretical probability is 1/8, right? Which is 0.125. And so we were really, really close to the theoretical probability, right? 0.003 off, which is really exciting. And what that did for students then, when we went through and made the list of all the ways that the 3 coins could land, and we saw the 8 possibilities, and that only one of them had tails, 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 and we said that it was 1/8, they believed that probability because they saw that we flipped this almost 10,000 times, and our experimental probability was 0.003 away. And in fact, seeing this just right here on the screen, I'm sure I probably have all ways that the coins can land, right? So that helps us go down the road of making the list of all those possibilities. So I think that's a really nice example as well to share. All right, let me keep going with some other examples. And then again, if you have any other questions at all, feel free to drop them in the chat. This canvas, by the way, that I just made in the moment is also available under the File menu, even if you don't have an account. This is My Library. So everything here is My Library. But all the way at the bottom is a public library called Examples and Templates. And in Probability and Data, there is a pre-made canvas with 50 sets of 3 coins. So there it is. But here's a pre-made canvas with 100 pairs of coins. And here's one with 100 pair of dice. So if you want to roll 2 dice 100 times, you can do this and count how many double sixes come up, right? The same idea, in generating lots and lots of data so students believe the probability. All right. Speaking of probability, I want to share an example with you using the area model of probability and how our graphs and scatter plots can be helpful. I've showed you a couple of the graphs, but not the scatter plots. So I'm going to go back to our task page. I'm going to click on lessons at the top. You can find this at mathigon.org/tasks. And I'm going to search for triangle because I know the lesson that I want to share with you is on the triangle inequality theorem. So this lesson I did a couple weeks ago. Again, I think it can be extended up and down depending on the age of the students that you work with. And this is the idea of what lengths can and cannot make a triangle. And so I first used a physical manipulative in class. I gave them all a piece of pasta and said, break this in 2 places so it does make a triangle, and then take another one and break it in 2 places where it doesn't make a triangle. And they did it on their desk, and they walked around and looked at each other's triangles. And then we talked about, all right, now you're going to break it at random in 2 random places. What % of time are those 3 lengths going to form a triangle? Kind of a classic probability question that involves the triangle inequality theorem. I'm taking this stick, breaking it in 2 random places. When will they form a triangle and when will they not? And so here's a Polypad that I shared with them. Let me zoom in a little bit. I did a couple examples as a class together, and then I had them go off and do a bunch of examples on their own. So this is a line of length 10 that I've put on the canvas. Here are 2 dice I'm going to roll, and this tells me where to cut the stick. So I'm going to cut one of the cuts is going to be at 6.8, and the other cut is going to be at 4.8. So I'm going to cut this stick in 2 random spots. I'm going to use the pen tool at the bottom, and the ruler allows me to draw a straight line. So one of the cuts is like 4.8. That's the 4.8 on the number line. And the other cut is like right here. And so that broke the stick into these 3 lengths, right? There's a length right there. There's length 1. Here's length 2. And here's length 3. So I'm going to find the lengths of those and put those in the table. This one is from 4.8 to 0. So that's 4.8. This one is 6.8 to 4.8. That's 2. And this length is 10 to 6.8. What's that, 3.2? I think so. And 3 and 4 is, yep, I think I did my math right. Let me know in the chat if I subtracted wrong. It's been a full day of teaching, and my arithmetic skills are sometimes not the best, but I'm pretty sure that's good. Those all add up to 10, and that does make a triangle because 2 plus 3.2 is 5.2, which is bigger than 4.8, but I can use a triangle at the bottom here to try to build it. So there's 5.2. Let me get to 4.8, see if I can get 4.8 and 2 without wasting too much time trying to do that. There's 4.8. I got to bring it down a little bit. Oh, I'm really close right there. Oh, there we go. It's going to work. I'm off by 0.1. So that's a yes. I'm able to make a triangle there. So then I'd have students go down, and I'm going to put 4.8 and 2 in the makes a triangle part. And this is a good connection to the theme of this webinar, data and statistics. I'm going to go 4.8 and 2, and it puts that green dot right there. That does make a triangle. I'd have students do a whole lot more of collecting data, and maybe they do 20 of them, and they'll have a number of green dots and red dots on their canvas. And then I had them share their data in a Google form. So then I got a spreadsheet with all the data, and I want to show you what it looks like when I put all the data together. I'm going through this kind of fast just to give you an idea of how much data our scatter plots can handle, right? There's a point. Obviously, if I had gotten like 1 and 8, the 2 lines would have been 1 and 7 and 2, and that does not make a triangle, right? Because 1 plus 2 is less than 7, and so this would be 1 and, what was my B there, 7, and this will be red way over here, does not make a triangle. But let me show you what it looks like. I'm going to go back to our task page and search for triangle inequality theorem. And here, this is just the whole lesson plan. Here's the canvas with all the data, right? That is the table. I just copy pasted that table from a Google Sheet. I made a couple tables so it could handle all the data, but that's the data from all of my classes, right? I think I'm zoomed out as much as I can, but these are big tables of data, and they're all linked to this one scatter plot that looks like this. Right, I'm going to zoom in on it really big here so you can see. There's the scatter plot. There's all the ones that worked and didn't work. And it was this beautiful aha moment in class where kids like, first of all, they're like, whoa, it makes a triangle, which was cool because we were trying to make triangles. And then the data was split up into these 4 triangles, right? And it seems like 1/4 of them are 1/4 of the triangle is green where it works. And so the actual answer is that this will make a triangle 1/4 of the time. And a really nice visual, a great connection between the probability, trying to break the stick, putting the data into these table, and the scatter plot shows it really well. And then we had the follow-up conversation about like what's happening down here. Why are these ones not making a triangle? Why are these not? Why are these not? And why are the green are? So I thought that was a really nice activity as well. All right, let me keep rolling here. I'm just going to go click on Polypad to get a blank Polypad, and I'm going to put 12 dice on the screen here. So I'll go to probability and data, coins, dice, and spinners. 1, I'm using the copy button. There's 3, there's 6, there's 12. And I want to transition and talk about mean, median, mode, and range. So kind of some statistical analysis and how the tools here might be helpful for students creating a really good picture in their head of what those 4 measures of center tell us about a data set, mean, median, mode, and range. And so let me just roll them all first. All right, and then I'm going to put them in order. So we have 1, 1, 1. Bear with me as I put them in order. A lot of 1s, no 2s. All right, this is what we often have students do with a data set when we want to find the measures of center. We haven't put them in order, right? And I really like having students create a visual model of a mean of a data set. So rather than just right now adding them up and dividing how many there are, when they're first exploring mean, I think it can be nice to do an activity like the following. I'm just going to draw a line here. And I'm going to build like 1, 1, 1, 3, 3, 4, and so on. And I'm going to do that with our number tiles. So I'm going to go over here to number tiles. And under each dice, I'm going to put the number of blocks. You can see it kind of snaps to the line, which is kind of nice too. So I'm sort of making a graph of these, but with the number tiles. So there's 3. Again, I'd have students do this. You're kind of just watching me. But I think having students do this is where the power of the activity comes in. So here's a 4. Let me get one more up here to make 5. Oops. I want to copy this one for 5. I need a couple 5s. I'm just clicking and dragging using the C button on my keyboard to copy it. So there's 5. And one more will make 6. Right? And before I even mention the word mean to students, I just have them do this. And I say, try to move it around to make all the piles, all the stacks the same size, right? No vocab, just can you move the dots around? Like imagine the dots on the dice can be moved. Can you move them around so they're all the same size? So let me see how I can do this. We'll go over here, maybe these 2 over here, one of these. Let's see if I can get them all close to 3. Right? Wouldn't that be nice? I actually don't want it to be exactly 3. Let's see how I do. There's a 3. There's a 3. Oh, we have 2 left over. Awesome. So it seems like there's 2 left over. It's stacks of 3 with 2 left over. And depending on the age of my students, I would actually say I need to take these 2 and split them up into these 12 groups, right? So it's going to be these 2 divided by 12. So it seems like the mean, I'm going to go to a text box. I haven't used a text box yet. Just say the mean is 3 and 2/12. Actually, let me show you our equation tool. That's the text box. Down here, there's an equation tool where I can type in fractions. So I can say I'll make 2/12 1/6. So we'll go 1/6 and the number in front. There's my mean, 3 and 1/6. It shows me that as a decimal. That's a feature I can turn on and off. I'll do that under the customize UI. There's all sorts of ways to customize the canvas that you want students to engage with. So I'm going to open that. I'm going to turn off evaluate equations. I'm going to turn that off, click save, and you can see the decimal goes away. But there's the mean, right? What I want to do is I'm going to undo this whole thing. I'm actually going to lose this because I want to go back to the beginning and show you something else I can do to find the mean as I use these number tiles. So I was just taking them and I was moving them around, but I'm going to copy this and move down here. And one of the options that is wonderful if you're exploring factors of numbers, I'm going to merge all these number tiles together, right? As we've talked about, every tile has actions associated with it that show up in the action bar. The roll action is there. One of the actions with the number tiles is merge. I'm going to click merge. Watch what happens. Whoop. It made one group of all those number tiles. And as I click this black handle, it's going to take those number tiles and try to arrange them into rectangles. So you can see I have an even number. Is it divisible by 3? No, there's 2 left over. One's divisible by 3, and so on. But I'm trying to sort it into groups of 12. So I'm going to turn on my grid background and stop when I get to 12. That's 5, 10, 12. Oh, so I can see, and then I can split them up and maybe make these a different color. I can see that I have 3 groups of 12 with 2 left over, right? There is the mean, 3 divided by 12. And what happened here, if I undo this whole thing, this merge button is adding them all together, right? There's the addition of finding the average of a set of numbers. I've added them all together, and now I'm splitting it up into groups of 12. I'm dividing by 12. I think that's a really powerful visual for students to think about how to find the mean of a data set, right? It's putting them all together, but here you can actually see them all coming together. So there's the mean. Then we could certainly find the median, 1, 2, 3, 4, 5, 6. There's the median right in the middle of those. We could talk about which one comes up the most, right there. That comes up the most, and 6 minus 1 is 5. Right, I'm going to turn off the grid background. So that's, and then I think this can be like a nice activity just for students to explore, like practicing finding the mean, median, mode, and range, right? Here's 12 dice. Try it again. Like, what happened the second time? Did your mean get bigger? Have students make a prediction. My mean was 3 and 1/6. Is this going to be bigger or smaller? Roll them again. Right, do it. And then after I've practiced mean, median, mode, range for a while, I have students try to make a prediction, right? Here's 12 dice. If you had to predict one of them, you can only predict the mean, median, mode, or range, and you want to be right, which prediction would you be most confident in, right? Well, the 1 was the mode. I feel like I'm getting a lot of 1s, right? I think that's great conversation there, right? Which one are you most confident in making a prediction in? But then I remember last year when I was doing this in 6th grade, I pulled up this canvas of 100 dice, and I said, we're going to do the same thing now. Predict 1, the mean, median, mode, or range. I think I even rolled it once, and I didn't have them calculate it, but I asked them to think about the mean, median, mode, or range. And surprisingly, this gave me really good feedback as a teacher. Not every student said the range is what they were most confident in, right? I feel really confident that a 6 and a 1 are going to come up, right? Did I get one? Yes, I got a bunch of them. Range is 5. I feel really confident that a 6 and a 1 is going to come up. Range is 5, right? I could probably make some pretty solid guesses about the mean and maybe the median. Mode, I don't feel confident in making a prediction about. But when I saw that not all of my students jumped to the range, I knew that I hadn't done a good job of like really diving into the details of what each measure of center and range was telling them about the data set. So then we kind of backed up and talked more about it. And then we talked about, all right, if you had to rank them in order, right? Range is first. Which one is second? Which one is third? And then we did it a couple times and students saw how they did. So I think that is super fun. Again, any questions at all, drop them in the chat. I have one last activity to share around box and whisker plots, and then I will open it up to other questions as well. All right, so I need a canvas with 20 dice on the screen. I think for the purposes of this webinar, I made it in advance. It's not anywhere that you can find it because you'll see it's not much there. It's just 20 dice on the screen. Oh, it's not that one because this is my final version. So I'm just going to go to a new Polypad and put 20 dice on the screen and roll them all. I've taught box and whisker for a couple years now and found that it's a really hard concept for students to really understand what a box and whisker plot is all about. The quartiles and the median and the outliers and all that. So here's one way that this might provide some assistance for students. Here's 20 dice. I'm going to roll them. I'll put them in order. Bear with me as I put them in order. 1, 1, couple 2s. Looks like I got a lot of 3s here. 2. Oh, I missed a 1, which is easy to fix. I can just put it right here. There's 3s, 3s, 3s. I found too with my students, there's just something like nice and colorful about the dice and the spinners and the probability tools that it feels like somewhat joyful for students to like engage with these tools, not as tedious as like, here is 20 random numbers, or go to Google and enter in 20 random numbers. Rolling the dice is kind of fun. And then, kids will talk about, what did you get? What did I get? I think it adds some levity to the class. All right. So then for the box and whisker, I'm going to put a number line on the canvas. So I'll go to my number line. There's a number line. I want to go from 1 to 6. I can change the size of the number line under the gear. And I know for this activity, after some trial and error, I want a width of 8. So there's my number line up through 8. I'm going to put on a grid background, have the dice snap to the grid, and have this do the same. All right, so now we would find the median, right? I'd talk with students. The first thing we want is to put a line at the median. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That looks to be in the midpoint. Let me just check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So yes, 3 is the median. So I put a line right here, as you may know with the box and whisker. And then you find the median of the lower half. 1, 2, 3, 4, 5 is 2. So we put a line there. And then the median of the upper half, 1, 2, 3, 4, 5 is 5. Right? I'm off a little bit. There we go. And that's the box. As you may recall, that's the box. And then you make the whisker to the lowest point is a 1. I did get a 1. So we draw this to the 1 and we draw this to the 6. But what I think my students have had trouble with over the years is really this idea that each of these sections of the graph has the same amount of data points, right? They're different sizes, but they're each containing the same amount of data points. So I think there's value in taking these 5 and like putting them here, maybe like even like spinning a little bit and being like, this part of the whisker has 5 data points. 1, 2, 3, 4, 5. This one has another 5, right? Those 5 are going like right in here in that box. These 5, 1, 2, 3, 4, 5 are going here. I could leave it like horizontal if I wanted. And these 5 are going here. That it's taking the data and it's splitting it up into these 4 equal chunks. And the 2 chunks in the middle get this box around it because a lot of the data is in there. And then the 2 on the end get this whisker. I think just doing that like helps them understand what's happening with the box and whisker. You can actually like take the data and move it around the screen. And then if I wanted to put this data in a chart, which I do want to, so I'm going to do it. I just want to show you that we actually have box and whiskers, right? So I just made this whole box and whisker. I'm going to just get rid of the label here. Let me enter in the data. I got 1, 1, 1. How many 2s do we got? 3 2s. I have 5 3s. 1, 2, 3, 4, 5. 3 4s. 1, 2, 3. Let me zoom out a little bit. 4 5s. So let's do 1, 2, 3, 4, and then 2 6s. There's my data, and I'm going to put a box and whisker chart on the canvas. So there's my box and whisker chart, and just like before, when I click on this table, I'm like zoomed in on the table, but there's the table, right? There's my table. I can drag this to the box and whisker. Oh, nice. And there's the box and whisker that I can make the same length as the one that I just made. And you can see that I made the box and whisker correctly. Always a chance I'd mess up when I'm doing a box and whisker live, but there's 2 and 3 and 5. And so then I could roll the dice again and maybe make a different box and whisker, and students could compare what's the same or different about their box and whiskers. You could have them make one and then check it. Right? I think if part of the goal is having students make their own box and whisker, this ability to make one and then check it can be a nice activity for students. And then the final activity to share about a box and whisker, I'm going to go to our task page, mathigon.org/tasks. This task is called Perceptions of Likeliness. Right? This is the whole lesson plan. I'm not going to read it. It came from an article all the way down here by Rick Wicklin, which you can go check out. The idea of this lesson is there's a link to a Google form that you can make a copy of, and you'd ask students, or anyone even, I did it with a bunch of teachers for practice, what they think these phrases mean on a scale from 0 to 100. So if I said the chances of something happening are almost even, what would you say if you ranked that 0 to 100? Almost certainly it'll happen. Almost no chance. Better than ever. Chances are slight. Highly likely, unlikely, and so on. Again, you can go learn more about this in this lesson plan, right? This article, I think, came from the United States military, where they were finding that different members of the military had different interpretations of what these phrases meant. And these phrases were appearing a lot in reports. And so they wanted to get a clearer sense of what they mean. So I pulled a bunch of teachers and I got a bunch of data, and I put this data into a chart, which is here. I'm going to just pull it up in Polypad to show you all that data in a table. It's my perception data. There we go. So there's all this data. You can see this first row is someone that's thought almost certainly meant 95 and highly likely meant 80 and very good chance was 85. But I want to make a box and whisker of this. I think this is a really good example of a box and whisker plot. So let me go to charts, probability and data, box and whisker, and check this out. I'm going to attach this data to the box and whisker. I think this is a really fun moment to check out. Watch this. Here we go. Oh, it's covered up. It made a box and whisker for every row in that table. I'll make it bigger, right? There is the box and whisker for each column, right? It's got a box and whisker for each column. Sorry, I said row. So it's created a box and whisker for all of the scores for almost certainly is going to happen. And like great noticing and wondering can happen with this box and whisker, right? Let me just zoom in a little bit, right? What does it mean when the box is really small, right? Here, this almost even, right? 50% of people who answer this question are right there at almost even, which makes sense because that feels like it's about 50. You may have spent time exploring an outlier in a box and whisker. I think that's a data point that's 1.5 times away of the mid-quartile range from one of the quartiles. You can check me on that. But I can toggle these on and off. You can see when I click on the box and whisker, one of the options here is an outlier. So if I turn this off, those outliers aren't included. So if we look at the blue one of almost even, there's one person that said almost even was like 80%. Maybe they misread it. Maybe they typed the wrong number. Maybe they don't understand that phrase, or maybe that's what it means to them. But that's an outlier, right? And so when I click that, this is even more focused, right? This is like 100% of the data is there, right? There is the purple one and red one here don't look the same, right? This purple one is probable, and this red one is probably. I notice the median's the same. I notice the lower quartile and upper quartile are the same. The maximum's the same. When I toggle the outlier, there was one person that said probable was in the 30s, but probably they had an answer that was much higher. So I think being able to turn the outliers on and off that easily helps students understand what the outliers are and even have a deeper conversation about the data. And to do an activity like this in your class and have the conversations, have students go through this form and fill it out, talk to each other about it, and then put all the data, where did it go? There it is, into a table and create a class box and whisker and have those conversations, I think is a really powerful way to use these tools to explore data science. All right. With a few minutes left, just a few reminders of places to go and learn more. One thing to point out, under each section in Polypad is a question mark. Algebra, fractions, there's a question mark. So on probability and data, I can click on that question mark and it brings me to a tutorial page all about probability and data. I bounced around a lot tonight, might have gone a little fast, but you can always go back and learn more. You can also find that under the question mark here, under help. These are all the tutorials. So you can go to the fraction tutorial and learn all about the fraction tiles that we have and the algebra, geometry, and so on. This link right from the question mark, if you don't have a teacher account and lessons isn't appearing here, you can always get there just at mathigon.org/tasks. That'll get you right there. Or on Polypad, under this question mark, there's a link to our lesson plan page, which will take you right there. So all one-stop shopping there. And finally, our help and tutorial page, I've mentioned a few times, is mathigon.org/PD. I'll drop that. Oh, sorry. I'll drop that in the chat one more time. A great place to go, again, if you are new to Polypad and are interested in being able to learn more about all of the topics and not just data science. Here are some getting started pages, all of the tutorial pages that I talked about, and a bunch of webinars. If you're new and you're a secondary teacher, maybe go check out the webinar Back to School at the secondary level from August and Back to School at the elementary level. We've added a lot to Polypad since August. So you could also go to Polypad, and at the bottom of the tile menu is a What's New link. So you could go to What's New and you could scroll through everything we've added since August, since we had those back to school webinars. All right. And finally, at mathigon.org/PD, you can sign up for future events. Thanks for coming to this webinar, either live or watching it after the fact. We have one coming up in about a month on exploring geometry. So many amazingly wonderful geometry tools on Polypad. A month after that on exploring numbers and fractions. And then in June, we'll have a number of teachers come on and share how they've used Polypad in the classroom. If you're interested in being one of those teachers, let me know. I'll put my email and contact info in the chat in a little bit. And then here are the tutorials again for how to get your classes up and running. And we've had a wonderful guest speaker series over the 2021-2022 school year. A number of these have some recordings if you want to go check them out. But in a couple of weeks, Desiree Harrison and Jennifer Saw is coming in May, so you can sign up for our guest speaker series. All right, that'll do it for my presentation. It's been my pleasure talking you through a number of these things. If you have any questions at all in the few minutes that we have, I'm happy to answer them. If you're still here, that means there was some value and some good ideas for you of how you might use this with your students. You can leave a live stream anytime and nobody notices. So if you're still here, I will take that as good feedback that there were some things for you that were helpful. Hope to see you at future Mathigon events. If you are on Twitter and you want to share your ideas of how you are using Polypad, I'm at David Poras. Mathigon is at mathigon.org. We also have accounts on Facebook and on Instagram. We love seeing how teachers are using this with your students. So please tag us in posts and ideas. I presented a range of ideas tonight, but obviously the more we share ideas with each other, the better. Finally, again, everything I've shared with you tonight is totally free and open and accessible for teachers and students around the world. All right. So thanks again for coming. I'll stick around for another few seconds to see if there's any questions. But I appreciate you coming out to this webinar and hope to see you virtually and or in person at some point down the road.